And see, standard arithmetic like 2 plus 3 times 4 requires us to evaluate multiplication before addition. For a computer parsing this string left to right, it has to scan back and forth to identify which operator takes precedence. Flattening this into a postfix sequence gives the computer a single linear path to follow. Notations like postfix, where the operator follows the operands, and prefix, where it leads them, completely eliminate the need for parenthesis and prec rules during calculation. The structure of the expression dictates its own order. The engine behind converting and solving these expressions is the stack. It is a last in first out data structure where elements are pushed onto the top and popped off the top. This slide ranks the operators. When we convert standard math into postfix, a higher precedence operator entering the stack will always force a lower or equal precedence operator out of the stack and into the output string. By filtering math through an ACT, you replace multiple parsing scans with a single pass operation. Let's trace the conversion of a plus b times c. Here's our input stream vertical operator stack and final output. Operands flow straight into the output string. The plus enters the stack first. Multiplication has higher priority, so it stacks on top. Parentheses change this process. A minus b divided by open parenthesis c times d to the power of e's. The opening parenthesis is a reinforced floor resetting precedence. When closed, every operator above it immediately pops to the output in reverse order. Parentheses are discarded. If an operator meets another of the exact same priority already in the stack, the left associativity rule breaks the tie. The existing operator is forced out into the output before the new arrival takes its place. The stack's mechanical push and pop sequence ensures the correct order of operations, delivering a clean output. String with no parenthesis. To evaluate a postfix expression, the computer reverses the roles. Numbers are pushed into the stack while operators trigger the calculations with postfix sequence 2, 3, 4, multiply 5, add, subtract. We stack operands 2, 3, and 4. Hitting multiply pops the top 2. Order is critical. 4 is operand 2. 3 is operand 1. They combine into 12, which pushes back on of the stack. This slide provides a more complex sequence for you to evaluate. Pause the video and trace this on paper. Remember to watch your operand order during the subtraction and division steps. The final answer is 52. You can use this trace table to audit your process. Every time an operator is processed, the stack depth effectively shrinks by 1 as 2 operands are replaced by their result. By shifting logic into mechanical rules, postfix evaluation ensures the computer processes operations in the exact sequence intended by human notation. Prefix notation relies on the exact same stack logic, just approached from the opposite direction. To manually convert an infix expression to prefix, you reverse the initial string, execute the standard postfix algorithm, and then reverse that result. Evaluating a prefix expression is just as direct. You scan the string right to left, pushing numbers onto the stack as you encounter them. This cheat sheet summarizes the two notations. The underlying data structure is always a stack. Only the reading direction of the scan dictates the format. Mastering the underlying logic of the stack eliminates the need to memorize separate algorithms, allowing you to parse and execute any mathematical expression.